In software development, offline and network scenarios refer to how an application behaves depending on the availability of a network connection, and each scenario presents unique challenges and opportunities for developers. Offline scenarios occur when the application is used without an active internet or network connection. This is critical for users who need access to data or functionality in areas with limited or no connectivity, such as remote locations or areas with unstable internet connections. In offline scenarios, the application must store essential data locally on the device, often using local storage mechanisms such as databases, file systems, or caches. This allows users to continue working with the application without requiring constant access to the internet. For instance, offline functionality can involve features like saving user-generated content, editing documents, or interacting with preloaded data. Google Docs, for example, enables users to continue editing documents offline, and when the device regains a connection, the changes are automatically synchronized with the cloud. This is done by saving changes to a local version of the document and then syncing those changes with the server once connectivity is restored. Offline applications need to manage local data carefully, ensuring that it is not lost or corrupted. Once online, these apps must perform data synchronization, which can involve merging data changes from different sources or resolving conflicts when multiple versions of the data exist. On the other hand, network scenarios involve applications that depend on an active network connection to function. These applications rely on real-time data from remote servers or cloud services, and any disruption in the network connection can impact the application's functionality. For example, many applications that rely on cloud-based services like social media platforms, collaborative tools, or online shopping sites are designed for constant interaction with the server. In network scenarios, the application might be fetching the latest content, updating user profiles, or sending and receiving real-time data such as messages, orders, or posts. Applications in network scenarios also need to consider issues such as latency, which is the delay between sending a request and receiving a response, and network reliability, which can affect the user experience. For example, if a user sends a message on WhatsApp, the app depends on a network connection to transmit that message in real time. If the network connection is slow or interrupted, the app must handle this gracefully by either retrying the operation or notifying the user of the issue. Networked applications often implement features like caching to improve performance and reduce the reliance on constant network requests. For example, a weather app might show previously cached data if it cannot fetch the latest updates due to network issues. Many modern applications are designed to work in hybrid scenarios, where they can function both offline and online, depending on the user's connectivity. These applications are particularly useful for mobile users who might be on the move and encounter varying network conditions. A hybrid application can operate offline when a connection is unavailable and then synchronize data with the server when the connection is restored. One common approach is the use of background synchronization to upload or download data in the background when the app detects that a network connection is available. An example of a hybrid app is Spotify, which allows users to download songs or playlists for offline listening. When the device is online again, Spotify synchronizes any changes made to the user's playlists or tracks, ensuring the content is up to date. For applications operating in either offline or network scenarios, it's crucial to ensure data consistency. In offline scenarios, this means making sure that data is not lost when the app switches between offline and online modes. This often involves implementing features like conflict resolution or version control, where the app needs to handle conflicting updates that might occur when the user works offline and another user modifies the same data while the first user is offline. A robust error handling mechanism is also important in both offline and network scenarios to alert users when something goes wrong, whether it's due to connectivity issues, synchronization failures, or other technical challenges. Overall, while offline and network scenarios present distinct challenges, Developers can use various techniques to ensure that the user experience is smooth and reliable, whether the application is online or offline. Effective use of local storage, synchronization protocols, caching, and conflict resolution can help create applications that are both resilient and responsive, offering users the flexibility to work in a wide range of environments.